I was so stuck. I'm not mad at him, but like,
What's up?
Can I ask a question about my
Sure.
you want those photos? I just want to make sure I understand why I got myself.
What's the part?
It's been very slow today. So your feedback was sorry. So my formatting was different, which I'm assuming is just the headings. Let's see. And then it's not quite 2 pages. I just want to make sure it's just that like the headings made it look very shorter. And I should have done like 2 top pages instead of 1.
Let me see.
I think.
So, where's the actual assignment?
Maybe like.
These margins are pretty out, and the spacing looks a bit different. The font looks a bit different.
It is different. It's what it's like.
And there's a big gap down here.
Yeah. Okay. So I just need to use the same font.
Well, I think mainly a lot of students kind of struggle to keep their length within and when we look at the shorter length here, it kind of lends itself to maybe not as much thought was put into some of these. It's close enough that I would probably be this bad. So you should email me requesting.
Okay. But in the future, I should just be a more verbose.
Yeah. Well, no, we don't want verbosity. We want deep thought. The length is kind of a proxy for if you're consuming this amount of space, there's a good chance that you're putting thought into stuff. But that's not really true either.
Yeah.
Because, what we don't want to make this is an essay where you're just kind of you're stretch it out.
Yeah.
Right. But, yeah, so in the future, you should probably just keep the normal template so you don't kind of arouse our suspicions. Make sure that you're writing and just dumping thoughts as deeply as you can on these topics.
Okay.
When you run out of things to say, there's a very good chance that you'll have more than enough to meet all the requirements.
Okay. I guess I do feel like I put in enough thought because like the last question was just where did the idea come from, but
yeah, well, send me a regrade request and I'll reread it and I'll decide. Okay.
Fair enough. Thank you.
Yeah.
I think that's. Just reverse your tires time. Go back to 0.
Testing 1 2 3. Testing. Testing 1 2 3. Testing 1 2 3. Testing. Okay, ladies and gentlemen, welcome to another week of EECS 494. This is your final week before spring break. I hope you're looking forward to it. A quick note, I'm currently in mourning, and so I'm probably not going to sound exactly like I normally do. I apologize. P2 Gold is going to be due on Wednesday, so I hope that you have been enjoying the Project 2 process. This is your chance to build a tiny game of your very own design for the first time, new code base. And so hopefully that's been a nice experience for you, kind of getting out of that nasty P1 code base A quick note, I've said in the past that juice is something you need to worry about for Project 2. In fact, it is not. It is not a required criteria on the P2 Gold rubric. However, it may still be worthwhile thinking about your juice and how to implement it, because it can improve your game's guidance, okay? Things like particle effects, things like color flashing, special effects with the camera, lighting, can draw players' attention to where you want it to be. And so think about that, okay? If we look at where we are on the schedule, yep, we are right in the middle of P2 Gold. You only have a couple more days remaining. You do have feedback available now, okay? You have video feedback from the grading team. You should also have feedback from our playtesting session last week. And so make sure you are using that feedback. You don't really want issues to reach the grading staff, okay? You can let issues reach your primary target customer, but you may regret that, okay? One of the very common, unfortunately, strategies in the business, have you ever heard of Steam Early Access? It's this notion that we are going to make our customers into our beta testers. We are going to release a game that is half-baked. Anyone playing Civ 7 right now? Anyone? No? We're going to release a game that's half-baked, and we're going to let our users find our issues for us. Sometimes this is hard to avoid. Sometimes you simply run out of money and time, and that's what you have to do. However, that will put the burden and the pain of all those bugs and issues and design issues onto your players, and they're not going to forget that, okay? So we want to be careful about that. In the old days, not to go on too long of a tangent, not to get too salty or bitter, but in the old days, when you would release a game, you would burn that software to a disk, at which point it is not possible to update anymore. Consoles like the Wii, consoles like the PlayStation 2, the Xbox, the GameCube, right, NES, Super Nintendo, many of the consoles throughout history did not have the ability to offer patches or live updating. If you had a bug in your software and you released this, that was how it was always going to be. And maybe you can do a second run in a few months of a new version, new discs, but chances are there was no fixing a bug if you let it out. These days, we can hot patch. We can go in and we can issue a day one patch. We can fix things as they come up. But it's a very different experience than the way it used to be. This is all to say that be very careful, because this course models how things used to be in the 90s, in the early 2000s, in the 80s even. It's not really possible for you to issue a patch once it gets to us, okay? So be very careful about that. All right, if you can, playtest with your friends, playtest with your family, grab random people off the street or in the buildings you walk through. I don't really care, okay? You can learn a lot by just watching random people play your game. And so take the opportunity to do that, and that will help you much more optimally focus your efforts, okay? What really matters about my game? What are my game's biggest issues? You want to target them in order. Have you ever been playing a game and you come across, let's say you're walking through a room and there's something out of place, or there's a little bit of glitchiness in the corner of the room. There's a tiny little bug, right? And you think to yourself, how did they not fix this? Did they not notice? Did they not care? Have any of you noticed any bugs in the games you've been playing? What everyone forgets is that bug, okay, that bug that seems so obvious, so quick to fix, how did they miss this, right? They must not have cared. Well, that's the bug that made it through. You never see the ones that get fixed, okay? And so it can be the case that 1 million bugs were fixed before release, but the bug you're looking at now, unfortunately, it was the 1,000,001 bug on the list, okay? And they just simply ran out of time. Imagine when you're playing a game and it seems fun, but it's a little bit buggy. I want you to imagine for a second all the bugs that you never got to see because they did get fixed. Okay? And so this is all to say that you can't usually fix them all. All right? Players will pressure and mess with your software in ways you will never predict. But you can prioritize your bugs, okay? What are the most common bugs? What are the most damaging bugs? If something just looks a little strange in the room, that is a much, much smaller deal than, oh, if my player walks into this location and then this location in this order, the game will soft lock and become completely unplayable and their save file will be bricked. They'll have to completely start afresh. That's a complete disaster, okay? And so, prioritize, all right? This course asks you to do a lot, and you do not have infinite time, okay? This is going to be a recurring theme throughout your entire career, no matter where you end up. So please get in the habit of prioritization. All right. You should be working on your P2 project management as well. This document goes over all the things that you're going to need to do in order to finish your assignment with full credit. This is the kind of assignment where, and I'll have to do some iterating on it, a lot of teams get wrecked by this, okay? They get their P1 project management back, and maybe their score isn't what they hoped it would be. Please look through the assignment. Please ask questions. If you're nervous, you can always come to office hours and have me take a look at your JIRA, okay? Let me know what I think your grade is likely to be. Make sure that you are paying heed to this, because this can be a great source of easy, cheap points, or can be a big source of lost points. So be careful, okay? All right. So, regrades. If you ever feel like your grade does not match the assignment spec, or that you lost points for something that's not in the assignment spec or in the rubric, send a regrade request, okay? That is not going to annoy me. It is not going to waste my time. If there is a discrepancy between how grades are being doled out and the assignment specs, that's a huge problem, and that's something that needs to be raised to my attention right away. Please let me know, okay? One big thing is that our grading policy was incorrect. The way that penalties were being applied in many of the earlier assignments was basically take the maximum possible points you can earn on this assignment, and if you are late or if you have an incorrect submission format, multiply that by 20, and that's your penalty amount. Can you tell me what happens in this grading scheme if, let's say, it is possible to get 100 points on the assignment? You had a really rough submission, so you got 15 out of 100. It's a very rough submission. But you also got a penalty on top of that. So 20% penalty. What is your final grade going to be? It's going to be -5 points, okay? -5 points. And that is not how a good grading scheme is going to work, all right? You should not be able to go negative by making a few mistakes on an assignment. The only assignment in this course that can go negative is your participation grade, your participation assignment, and that's because it begins, I think, with 0 points, and we need to go negative to subtract from other assignments. For instance, if you didn't contribute to your Project 1, then you're going to lose a bunch of points, and that's going to come out of your participation. In any case, so please let us know if you ever suspect or fear that the grading wasn't done properly. You are paying a bunch of money, or at least someone is, to make sure that this is done right, and so we want to make sure that that's done right, okay? On a lighter topic, you can make a game out of anything these days. There are game engines wherever you look. Mac OS Finder is not typically regarded as a game engine, but, well, here's Flappy Bird re-implemented in the Mac OS X Finder. This is a bunch of folders that have had their file names made out of emojis, and they are being edited in real time to mimic the gameplay of Flappy Bird. So I don't recall exactly what script this is. What script is being used? Possibly Python? Maybe something stranger like AppleScript. Okay. Okay, there you go. Knockout. Cool. Okay. So what did they use here? BirdY, dir, finder, AppleScript. AppleScript. Okay. So it looks to me like they're using something called AppleScript. One of the tough things about AppleScript is that it is not going to work super well on Windows or Linux, right? As far as I know, this is proprietary and locked down into the Apple ecosystem. One question: why would you learn something like C# as opposed to learning something like AppleScript? How many jobs are available for someone who knows AppleScript? How many things can you make? Unreal Engine recently unveiled a managed textual language for their engine. It's called Verse. One difficult thing about Verse is that it's completely new. It is proprietary. You really, at least at the moment, cannot take Verse and do something else with it. Okay? You are locked in to Unreal Engine's ecosystem, and thus you don't get as much value as you could out of learning the language. If you learn C# because you want to make games in Unity, can you use C# for other things? The answer is yes. Okay, C# is not quite at Java's level, but it's not that far off either. Okay, C# is used at many different backend and server software companies, okay, for many different things. It is used as a general purpose application programming language as well. You can make basically anything you want. The autograder for EECS 498, the game engine architecture course, what you are looking at right here, we got two people grading on Linux right now. Their game engine is being evaluated on Linux. That is written in C#. And so if you go and learn C# for your game engine, for Unity, you will gain a lot of value in many different areas by knowing that language. Not so much if you learn Verse or AppleScript. I'm going to get off the tangents now because we do have quite a bit to do today, all right? Our main mission, well, the last thing I might show you, did I show you the risotto code from Half-Life? Okay. So you have all done Project 1. You've now gotten most of the way through Project 2, a cleaner code base, hopefully less spaghetti. You have this notion of what spaghetti means, right? You're violating dry. You have a lot of duplication everywhere. You have maintenance sites, right? Many different locations in your code base where you have to remember to visit it in order to simply expand the content and feature set of your game. You don't want those. Okay? Coupling, hard coupling, where systems depend on each other in ways that don't make sense. Okay? That is spaghetti. Now, in a textual code base, you kind of have a feel for what that looks like. But I want you to know that all of these things that make a code base spaghetti, they are decoupled from textual languages. There's nothing about a textual language that says only C# can have spaghetti. Okay? The things, spaghetti is inherently logical issues, okay? And so I want to prove that to you. I'm going to show you a quick interview from one of the developers of Half-Life, and I want them to talk a little bit about what it looks like when your logic gets messy in a non-textual programming language. Let's take a look.
Back when you're working on Half-Life 1 or Half-Life 2 era stuff, you're not really coding in a language. To script all the level logic, you have to use entities. And these entities are like icons or like visual things inside the world. So when you are scripting, okay, first Gordon Freeman will walk in here, and then that'll trigger the door will close, and then you have to trigger this sound, and trigger that sound. Each of those is like an independent thing that like the level designer had to make, and then manually like connect to this other thing. So what happens is that instead of getting like spaghetti code, you have like paella code or like risotto code, where it's not like it's not a long line of all these words in this programming language. It's literally just visual noise of 100 icons and trying to remember which of those icons you attach that logic to. Yeah, you have to like create the trigger and then convert that into a brush entity and then add all the information attached to it. Or there's some stuff where you're not necessarily attaching the scripting to like a wall or a door or something, you're attaching the scripting to just this random point in space as a hack. It doesn't matter where you put it, but you have to put it somewhere. So,
right. So basically what he's saying is that the way their game engine and tooling was set up, they had to create logic in this way. Okay, if they didn't want to go in and write C++ code to handle this logic in a custom sense, they had to basically go in and do it visually. And different engines will have different support for that kind of thing. But you'll describe, right, you'll notice that he describes this as a hack, okay, which already gives you this sense that the Half-Life engine was made very well for certain things and not so well for other things. And that is simply the reality of, hey, we've got deadlines, we've got limited resources. We could invest a lot of time in fixing and adding features to our engine, to our technology, to our tools. But time we spend doing that is time we're not spending creating content for our game. And they must have decided that content is what matters right now. And so that is what they chose to do, okay? All right, so let's go ahead and get into it. Last time I showed you how you could go in and you could do some kind of basic 3D modeling stuff, some cool environmental stuff, with not Blender, but with a tool called ProBuilder, which is a very, very nice tool that you can add straight into your Unity editor. And that will allow you to very easily kind of manipulate certain things in your meshes, okay, in your environments, right? It'll give you a vertice mode where you can actually move things around very dynamically and reshape your environments, okay? And if you end up working on a 3D game in Project 2 or Project 3, and I would encourage it, okay? You've gotten a lot of experience thanks to Project 1 in the realm of 2D, and so jumping into 3D could be a lot of fun. You're going to learn a lot doing so. But I highly encourage you to invest in tools like this. Try and learn the basics. And if this is the thing that really is of interest to you, if it makes you feel good, if it makes you emotionally satisfied, artistically satisfied to go in and work on this stuff, then I encourage you to get Pro Tools, right? Or get ProBuilder. I encourage you to look into Blender. And of course, I'm going to shill EECS 298 again for next semester, where we will be diving very deeply into all of that stuff, okay? But one thing we did not manage to accomplish last time, we ran out of time, is right here. One day. Come on, Unity. Let's go. Ooh. Now that we have kind of a low poly, but a little bit more realistic, right? A little bit more atmospheric environment, it would make sense for us to pair this with an avatar that is a little bit more realistic as well. As we have not taken EECS 298, right, we can't really model this efficiently and quickly ourselves. But what can we do? Well, one thing I recommend you do is use the asset stores, the public sharing platforms available to you. One of those is the Unity Asset Store. If we want to search for a snail, we could do so. You go to assetstore.unity.com, and you will find really cool assets, some of them free, some of them very expensive. I think that there is a pricing tab, right? So I don't see any good snail models in here. But if you go to Sketchfab, have any of you used Sketchfab before? None of you, okay. Here's the play, right? You go there, you create an account, you log in, and then you can search for anything you want. You want to add Shrek to your game? You'll find a like shockingly large amount of models, and very diverse models at that. Low poly models, right? Creepy models, right? Shrek Wazowski over here. You'll find all sorts of models. You can find downloadable ones, animated ones. What we need is a snail, okay? And so let's go ahead and find one. This is the one I usually use for this demonstration. I like it quite a lot. Not only can you download these objects, but you can actually check them out just in your browser before you put in the effort to actually get them integrated and downloaded. This snail is looking super good, so I'm going to go to Download 3D Model. One thing that's a little bit tricky is that you need to choose a format, a downloadable file type with which to download these 3D assets. One of the things you'll quickly discover about the world of 3D is the lack of standardization on a particular 3D modeling file type, okay? They all have their own limitations. They all have their own downsides and upsides. The closest thing we have to a universal file format in 3D, well, things are changing, but for the longest time, FBX was it, okay? So downloading an FBX, you're going to get great support from every engine except Godot for the most part. So let's go ahead and download an FBX. And we will go ahead and extract that. Okay. We get this zip file. When you look in this zip file, you might be a bit confused. What do we see here? Well, we see source and textures. This is kind of an annoying way that a lot of models are distributed. But in textures, we have a lot of images that are used by the actual FBX model right in here in the source folder. And so what I actually like to do is I sometimes like to just take these and I just dump them all into the same folder, okay, with each other. We can then just rename this folder into snail really, okay? And what we're going to do is we're going to drag this folder, this entire folder, we're going to drag it into our project pane. I'm going to organize this a little bit better. I'm going to go create a folder. I'm going to call this characters. And in here, I'm going to create a folder called snail, okay? And let's delete this because I'm going to drag the snail folder in. And let's go ahead and drag it in. So snail, really? We'll just go ahead and drag that right in, go into it. And now, in here, we have a bunch of different files. We have 4. We have this snail right here. I'm going to unlock my inspector. Let's see if we can actually see it, drag it up. Here is our snail, okay? There's a couple things wrong with this snail, all right? Let's go ahead and drag this out here, see if it looks good. That actually looks not too bad. It's now right side up. But there is a problem, okay? Do you notice anything about this snail? I noticed a couple things wrong with this snail, okay? Look at our current snail and then look at the big snail. Okay, what's wrong?
It's too big and the colors are off.
Yeah, the colors, the materials, to be more accurate, are messed up, all right? We want a snail that looks more like this, right? We've got kind of a shiny shell, okay? We've got this kind of snail skin area over here. The colors are great, but we don't have that. We also would say that this snail is too big compared to our current visualization for our snail, and our new one is too big. So we can go in and click on this FBX, and we'll see that there are a ton of import settings, okay? One of the toughest things about dealing with 3D in Unity is that when you want to bring in a model, you have a ton of different ways to bring it in. And some of those will result in disaster, and others will result in a really nice model that looks and works great in the engine. So you just have to get used to kind of playing around with these settings to get it just right. One of the first issues is scale. Thankfully, this is a super easy one to deal with. Scale factor under the model tab, we can just set it to 0.5, and then at the bottom, there's an apply button. All right, we can click that, see how we feel. That looks too small to me. So I'm actually going to change it to 0.75 and click apply again. That looks way, way better, okay? Now, we look at this snail and it just doesn't look very good, right? The biggest issue is the materials. They're all messed up. Well, thankfully, there is a materials tab over here, okay? And if you actually open up, this little snail FBX, you can see that it has geometry inside of it. You see this right here? It has a bunch of geometry, but it also has a material. The problem is I can't edit this material. It's inside of the FBX. It's inside of that model. And so if I want to fix this, and I have to, otherwise it'll look like this forever. If I want to fix this, I have to click on the object and go to Materials and then go to Extract Materials. Okay? This will kind of separate that material that my model is using. It'll kind of pull that material out so I can mess with it. Okay? And that's what we have to do. Now, this material is all messed up, but if you remember what we talked about with regard to materials, what is a material? Well, it's basically a collection of assets and a shader that define how something will render. So the classic example here is, look at the table in front of you, right? It is vaguely white colored, but it looks different from this white board, okay? And this whiteboard looks and feels different from this wall. All of these things have the basic color white, but they are different, okay? They look different because the way a material works is more than just what color or albedo it has, okay? All right, so when you click on this material, you can see that default albedo, right? That's the most obvious thing you can change, okay? And when you mess with that, you're going to see the change immediately. But when we downloaded this model, we got a few textures, okay? We got a snail diff image. I don't know what diff means, but this kind of looks like color, doesn't it? This is the basic color of the snail. And so I'm suspicious that I can drag this file right into albedo and look at that. We could probably stop right there. And that looks dramatically better, okay? But here's a takeaway for you. When you are importing models, this is not just a consistent algorithmic thing. You often need to go in there and experiment. You will sometimes download models that are really messed up, okay? The person who created the model did not take EECS 298, all right? They created a bogus model. Maybe it looks good, but it's kind of messed up, not very easy to use. You have to go in and kind of fix it, okay? And so that's what we kind of just did. We have snail spec. Spec suggests specular, which means maybe we want to use this for... I'm not really seeing much. We could try using it for metallic. How's that look? We're getting some of that shiny vibe. I'm kind of liking that. We could have also tried to use it for normal map. This is internal ground ambient occlusion, AO texture. Is there an ambient occlusion? There is an occlusion, so let's drag that and see what happens. Very little happened, okay? So maybe it wasn't that important. But in any case, I'm happy with this right now. This model looks good, okay? We can see how it looks in the gameplay by just running it. That looks really nice. Question?
Yeah, why isn't there a standardized way that this is all done? Like, I feel like it's probably been this way for years, right?
So that's a very, very good question. I think there's an XKCD about this. Hold on. So this is an XKCD, I think, relating to standards. Yes. Okay. So here we go. Have you seen this one before? So this relates to technology standards, right? For instance, AC chargers, character encodings, instant messaging. Okay, how do we send messages across on Android versus iOS? Okay, situation, there are 14 competing standards. 14, it's ridiculous. We need to develop one universal standard that covers everyone's use cases. Yeah. Now soon, there's going to be 15 competing standards, okay? And the text is, fortunately, the charging one has been solved now that we're all standardized on mini USB, or is it micro USB? Shit. Okay. So that's one of the reasons, right? It is difficult to standardize on, well, anything. right? Often you have a lot of different parties who have different motives, they have different needs, and so they might be able to produce a standard that works really well for them, but it works poorly for one of their rivals in the industry, okay? Or maybe their rivals don't like the idea of their opponent owning the standard for the entire industry. That's a bit of a strategic issue. And so they create their own standard despite one being existent, and it's a problem, okay? Recently, I think USB-C became a official standard for all smartphones in Europe. And so in that case, kind of a governmental body came in and basically said, hey, everyone, it's just USB-C now. You must have it, okay? And that kind of can make that work. So one issue is that FBX, right, the standard that I told you was kind of the universal one, it's closed source. It's proprietary. It's made by a company called Autodesk, which actually has an office in Plymouth. One of my assistants for 494 works there now. They haven't been super forthcoming. They're not super easy to work with. They do provide an API, but it's kind of limited, and there's some licensing things with it. And so people don't like FBX. If it was open sourced, possibly it would become that universal standard, but people want to avoid it. And so they create other standards. Pixar creates their own standard. The Kronos group creates their own standard. In any case, 3D modeling is sufficiently tricky, and there's so many things you can do in a 3D model, in a 3D character. How are you going to handle animations? How are you going to handle particle effects, okay? How are you going to handle bones and armatures and different drivers that affect those armatures? What is a driver? One 3D modeling program, Blender, has this concept, but maybe Maya doesn't. I think it probably does, but maybe it's called different. In any case, one of the things you'll discover in EECS 298 is that these 3D modeling programs have a million features. If you want to make something as advanced as a major film or game, you're going to use so many of them, and they're very unportable. Certain things are portable, like geometry, vertices, edges, faces. Where are they? How are they rotated? Right? How are they parented to different objects? Some shaders are portable, okay? But not all of them. You use a shader that's spicy or different or customized even a little bit, and you're toast. You will have to remake the shaders that you had in your beautiful Blender program. Your model's beautiful in Blender, but when you bring it into Unity, in many cases, it's going to look like it used to. It's going to look like this, okay? And you have to actually know the material and shader situation in Blender, but then when you bring it over to Unity, you have to then recreate all that in Unity. So it is a mess. The world of 3D is an extremely important world, but it is a very messy one, okay? And so there are many different factions at war in the world of 3D, okay? And if you can unify all that, then there's a lot of money to be made, I'm sure. But good luck, okay? People have been trying for a long time, and they have failed. So, any other questions? Okay, so here's a question. This is really pretty, but how are we going to use this, okay? We have this beautiful snail model. I'm going to call this actually the snail view. I could also maybe call this the snail costume, because this snail is only here to look cool. Okay, it's not going to affect our gameplay at all. It will remain the exact same. How? Well, here's what I'm going to do. I'm going to drag the snail view in here to create a new prefab. Now, I can just throw these snails around however I want. But what I really want here is I want this player to look like the snail, okay? This player, if I look at the game object, has a visuals game object. And in here, we have the eyes, okay? Which I do not care about. They're gone now, okay? They've got the cube. It's gone now. We're going to get rid of the body as well. What is this, actually? Oh, this is the trail render. Okay, I don't want to get rid of that. I do want to get rid of this cube, but that cube is not on this game object, it's on this one. I'm going to turn off the mesh render, and boom, there we go, okay? I'm going to drag this snail right in like that, okay? Look at how it's kind of squished. Okay, that doesn't look quite right. Let me get it back to normal here. Okay, maybe like a 200. This is looking kind of big to me. Okay, so I'm going to multiply all of these by 0.75. Okay, did you know you can put a math expression into these fields and it will resolve? Very cool stuff. Okay, that looks way better. But if you recall, our previous player was looking kind of north, and our snail is definitely not. Okay, so yeah, that doesn't look quite right. When we run the game, I'm guessing this is going to look a bit strange. Let's see what happens. This looks kind of like I'm constantly drifting, right, in a car. Right? You can hear the screeching. You can see the tire marks now. So what I can do here, this shouldn't be too hard, is I can simply rotate. Oh my goodness, that looks strange. Okay, let's rotate -90, and then what I'm going to do is I'm going to kind of resize this, okay? Actually, what I'm going to do is I'm going to pull it out of the object. Pull it out of the object. Now I should be able to rotate it like this without it deforming. The problem is, because my object is parented to other objects that have their scales messed with, my child object gets really weird transformations as well. So I think now I can drag my snail in, yep, and it will keep everything looking pretty good. I want to lower the snail so that's kind of on the ground here. Let's see how that looks. And there we go. Let's try it out. Not too bad, okay? Looking pretty good. Okay, I can go get chased by the enemies here, all right? I can go in to my little cave. Okay. We can go through our water here. That water's looking kind of basic. I might want to give it a texture. If I'm really serious, I might want to give it kind of some subtle motion with a shader, a vertex shader. Make it move up and down. Give it some waves. Okay. All right. Exploring our cave. All right. That took, I think, only about 15 minutes, and I was explaining for most of that. And so, don't underestimate the power of aesthetics in your projects. When we talked about your aesthetics really not mattering very much on Project 1, that was on Project 1, okay? We do want to think about aesthetics and juice when it comes to theming, telling a story, motivating the decisions the player will make in their gameplay, okay? That stuff does matter, and if you can immerse the player, then you can really help them out a lot, all right? An example, if the player sees that they are a snail, if they truly understand that they are a snail, they look like a snail, they sound like a snail, okay? They will also understand why their character is so slow and why their character cannot jump, okay? So please be careful with your aesthetics. Consider putting at least a little bit of time into them. And if you make good decisions, if you use resources like Sketchfab, then you'll be able to get really good results very, very quickly, okay? Or at least results that are good enough. Does anyone have any questions on any of this? When you introduce something that you did not make into your project, what you should do is you should create a little text file, okay? Credits.txt, drag it into the root of your project, and then put the link in there, okay? In this way, we will know that you didn't make this, and we can go look it up later, and you'll be just fine, okay? All right, cool, very good. So, what I would like to do now is I would like to show you and implement some juiciness effects with you, okay? By the way, in addition to opengameart.org, Sketchfab, right? Sketchfab is not even missing here. It's an old thing. Sketchfab.com. There's opengameart.org, which is really great, okay? Lots of audio, some models here, some sprites here if you're making a 2D game. Freesound.org is really good if you want audio, if you want sound effects, if you want vocals, okay? Super good there. Ambient CG is really good as well for textures and materials, all that stuff. Remember ambientcg.com. If only you know where to look, you can find everything you need. In fact, you know what I actually want to show you right now? There's a famous game. It actually blew up on Reddit for this reason. This is a game that was made by a, I think, first-time game developer. He was not a programmer. He was not a 3D artist. But he did have some technical art knowledge, okay? And so he was able to basically find assets out on the internet, bring them together, and make them look and work cohesively. And so I want to show you this trailer really quickly. This is a game that was made almost entirely from pre-existing assets.
Are you awake?
It was just a dream.
No, it's okay. Tell me what happened.
I saw a fox looking for her missing cubs. And along the way, the land told my story. A path was illuminated before her, and it led to something ancient. Something with answers. So she ran. It's a difficult path to the first tree, but each of us must eventually take it, including me.
Yeah, and David Wheel, the creator of this game, created a lot of very successful YouTube videos kind of documenting the process and kind of explaining how he was able to do this. In any case, the game does not look like it was just cobbled together from a bunch of different assets, an asset flip, as it's sometimes called. It is still very high effort, and a lot of care was taken to make sure all of these disparate assets from the far corners of the internet would work together and look together in a very cohesive way. So, yeah, don't feel bad about using external assets, but do be careful in how you use them, all right? Do think about it. Okay. So what I want to do is I want to show you some more elements of juice, okay? Juice is something that will be a required criteria on your Project 3. And so this is something that you do want to at least start thinking about. Remember, for your P2, a tiny little bit of it, okay? Some light seasoning can go a very long way, all right? Think about Guru, right? When you get hit by a spike enemy, some red particle effects go flying out. That is all of the juice you need to sell what just happened. It's very clear what happened once you see those red particles. Likewise, when you reach the exit, the flag, okay, confetti, okay? Nice little bit of juice, nothing crazy, nothing too expensive, very nice, okay? I want to show you some footage here, all right? This is an indie game. It's about spaghetti. This is a horror indie game about spaghetti. The mission here is you need to keep your spaghetti warm, right? Because it's no good if it's cold. And the way you're going to do that is by slapping it, okay? And so what I want you to pay attention to in this footage is how nice it feels to slap the spaghetti, okay? And then what I want you to notice is, why does it feel so good? Let's take a look. You think, I can't believe I'm learning this in a college course, right? Okay. The question remains, and it is a serious one. Why is this spaghetti so uniquely satisfying to slap? If you ask yourself, why did the developer put so much effort into the spaghetti and slapping it? Well, it's literally in the title, okay? If you're going to name your game Spaghetti, if your main gameplay mechanic that you're going to do 100 times is slapping the spaghetti, you'd better make that mechanic fantastic. You'd better make it feel incredible. It's as if you go to play Super Mario Brothers and the jump feels off. Can you imagine that? The whole game would be ruined. And so, the question for us is, how did we make this spaghetti so satisfying? When the player slaps this spaghetti, there's absolutely no confusion about what is happening. This spaghetti is spaghetti, and yes, it is being slapped. Okay? There's no ambiguity here. There's no confusion about the state of the game or about what just happened. That is what Good Juice does. It clarifies everything. So I'm going to play this really slowly for you. And I want you to kind of, hold on a second here. I want you to kind of just relish in it, but I also want you to take note of what is actually happening as if this were all happening in Unity, because it almost certainly was made in Unity. Playback speed. Okay, here we go. Watch carefully. What do you notice? There are a couple things here. What do you notice? Come on. Some particles. Yes, you can see them flying through the air, right? And they're kind of, brownish particles. Looks like it could be the sauce, okay? Flying, all right? And if you've ever tried to slap some spaghetti, that's kind of sort of what's going to happen, right? If you try and slap any object that is not very rigid, okay, that is composed of a bunch of little pieces, in this case noodles or sauce particles, this is what is going to happen, okay? What else is happening here? And I'll keep showing it to you, right? Yes? Yeah. What we've got here is a scale change. Okay, if you look at this, we have this object scaling up and down. And I want you to take note, this looks strangely like a spring. It's as if a spring is getting hit. Okay, when the slap comes down, the spaghetti compresses. Its local scale, transform.local scale goes down, but then it comes back up, it kind of springs back out, and then it settles down to a neutral state. It is a spring in 3 dimensions. Okay? Any of you remember Hooke's law from Physics 140? Okay, that's going to come up really, really soon, okay? It's going to be back. What else? There's one final big thing that we've missed. Yeah. The sound, right? You get that sound, right? Your eyes are telling you that the spaghetti has been slapped. But in case your eyes miss something, maybe you're looking away, all right? You have an additional sense to confirm, to back up your eyes, your vision, that this is a slap, okay? The more senses you can involve here, the more sure your player is going to be of the game's state, all right? And that's what Good Juice does, right? It clarifies the situation. And so, as funny as it might be, this is a big deal, okay? Juicy spaghetti in this game is a big part of why it's fun to play, all right? Another thing that I would like to show you, okay? Sometimes, Juice is also about giving a sense of timing and rhythm and professionalism to a game as well, a sense of charm, a sense of personality. This is less important to me, okay, but it is still super useful. I'm going to show you a game. It's a game called F-Zero GX. Has anyone ever heard of it? It's a futuristic high-speed racing game. I'm going to show you the intro for a racing track in this game. And I'm going to show it to you without any audio at all. I want you to pay attention to this video clip right here, okay? And also pay attention to how you feel emotionally as you watch it. Okay. Are you excited to race? Yeah? No? I thought it was kind of cool, but yeah, it's kind of a little bit lifeless, right? A little bit lifeless, not too exciting. Let's try again. Did you notice anything in particular beyond just, oh, there's rock music now?
It was synced up, but the camera movement was synced up with me.
Exactly, right? So, music, right? Music can be very impactful for setting a mood, but you know what's really interesting? And we forget about this. In the old days, music was used to, help people relax, right? And to put them in a certain mood. But you know what it was also used for? You know what music was also used for? Have you ever heard of a drummer boy? So drummer boys, okay, let's see if we can find it. Drummer boys were basically part of military units, and they would often have an instrument, okay? And they would play this instrument, be it a drum, right, or a bugle, and they would play the instrument to basically issue commands and synchronize troops over a large area, okay? If you need people to communicate or do something, like move forward now, how are you going to communicate that? They didn't have loudspeakers back in the day, okay? So they didn't have radios back in the day. So they would use instruments, okay? And they would get the drummer boy to play a particular tune, and that tune would tell you what you're supposed to do now out in the trenches while people are shooting at you or attacking you, okay? It would also try and motivate you to go do things. So humans, in general, can be synchronized with music. All right? We can be motivated with music. We can be put into a certain emotional state with music. And thus, that is what you are seeing here. If you watch this again, you'll notice that the camera changes and shifts at every beat in this song. Okay? Pay careful attention to how the camera shifts. There you go, right? And so you can often use audio and music to direct your player around to get them to do certain things. If you put a lot of things in your game to the rhythm, okay, if you synchronize different elements of your games to a musical beat, your game will suddenly feel exceptionally professional in a way that usually only AAA games do, all right? And I care less about this usually because students, right? How many of us are musicians in here? You can go find music and you can time things up and synchronize them to the beat, but this is something that we just often don't get to. We've got bigger fish to fry. But if you enjoy that stuff, keep it in the back of your mind. It can be very powerful, okay? All right, did I show you the South Park clip this semester? No? Okay, I want to show you another means of implementing juice that's exceptionally easy, okay? If you have just one image, if you have just one little character model and you can't animate, you haven't taken EECS 298 yet, you can't animate, what can you do? Well, you can always do this, and it is exceptionally easy, all right? Watch how the characters in South Park walk. In the show South Park, all the characters look very flat, okay? They're very quickly made. How does the show convince you that the characters are walking, that they want to move, okay? That they have the energy to do so? Take a careful look at their legs in this clip.
Where's your car? We took the cab here! Damn it, mind to the shop! Hey! Help! Stop! Please, it's an emergency! Come on! Nelson! Nelson, I need to come over and use your computer! need to play World of Warcraft.
All right. How'd they do it? Yes. Exactly, right? The characters bounce up and down. That's all that they really need to do to get the point across that the characters are trying. Their intention is to walk. And you might say to yourself, well, that's very cheap looking, right? But the entire show is very cheap looking on purpose. If you don't know much about this show, it is a show that is produced, each episode, right, around 23 minutes worth of content, is produced in 1 week, okay? So you think the 494 deadlines are pretty tough, all right? Imagine having a very popular show and you've got a 20-minute show you have to make and you've got 1 week to do it, all right? And so the art style allows them to make the show very quickly. Most of the voices in the show are just the two main show creators. So almost everyone has kind of a similar voice. They do this. They want to, have a very quick turnaround time so that they can be as topical as possible. When new events happen in the world, they can create an episode that comments on those events and introduces different perspectives and ideas about those events. So, in any case, this is a technique that you can also use. All you need here is one image or one model. That's all you need to make this look surprisingly good, okay? Here's an example. This is a project I was working on many years ago, actually. This is a little art character here. When you order her to walk around, right, she will do a couple things. Number one, her position, her local position, will go up and down, okay? It goes up and down not on the sine wave, as if she's flying in the air, but on the absolute value of the sine wave. Take the sine wave and just apply absolute value, and you suddenly have a little bunny hopping, okay? And thus you get the motion that you want. But that's not the only thing here, because her rotation is actually on the sine wave. While she is moving, her sprite is actually doing this, okay? It also is doing this, right? And so you get this effect of doing that, right, combined. It looks really nice. You also get the Paper Mario turn effect, where instead of just warping her, right, when she looks in a certain direction, we actually lerp this by adjusting her scale, her X scale, okay? And that is how you can do it, okay? It's a pretty good effect. What's really important about this effect is that it works on anything. Nothing I just said is tailored to her character, okay? I'll show you another example, okay? This effect works on any sprite you want, all right? And all you need is a single image, and look at the personality that you get, okay? I think I heard some of you laugh when you saw the big chunky squirrel. All right, it works. It works. It injects personality into this character. It looks like it's waltzing up to you to fight, and it's too slow to catch you, so, it's going to be a problem for him. Another cool thing here is that when you look at the art character, if you have additional artwork, for instance, if you have an image of her with her back to the camera, you can add those sprites in easily, okay? For instance, when she walks away from the camera, you're going to see the image kind of flip to that, and it looks great, okay? So anyway, this is an easy way to get some juice as well. But again, the whole point here of the juice is to try and convince players of what is happening, okay? If you take this image right here, if you take this image of the art student and you just make it a white block, and it doesn't change its visuals, it does kind of move, right? You're losing information. Your player's brain has to work harder to figure out what this character is doing and what the state of the game is, okay? With this art, you can tell that she is looking off to the left. If you launch an attack with her, the attack is going to go off to the left, all right? If you pause the game, you can look at this image and you can still get a sense of what she's trying to do, even without any motion at all. If you don't have these things, your brain has to kind of look at multiple frames in a row to figure out what the character's doing, all right? And that uses more brain power, it's less satisfying, and has far less personality. So That is what juice is for, okay? It helps us understand what is going on. But it also lends a bunch of charm and personality as well. So what I want to do is I want to introduce you to the actual implementation of a lot of these ideas, okay? Because what you will find is that juice is one of the most time-intensive things that you can possibly choose to pursue on your projects, okay? Juice takes forever, all right? If you play a random game off of itch.io or off of Steam, games that are made by students, you will find they lack personality for the most part. They tend to be kind of generic, right? They don't have a lot of character to their characters, if they even have any, okay? And a big part of that is that juice is hard. It really, really is, okay? And it takes a long time. We're going to implement some stuff today and then on Wednesday, and I'll show you a bunch of cool techniques. Some of them from the Juice It or Lose It video that you watched last time. But we're not going to get through everything either. So here's a look at some of the stuff that we'll be doing, okay? These are basically just a bunch of effects that have been put on. And yeah, you could tweak these to make them look better and more tasteful. But this is just kind of a sample of what we'll be doing, okay? We have here a rainy scene, okay? We have these kind of retro rain particles coming down, but we also have these larger rain droplets coming down. And when the droplets hit the ground, they're very heavy, okay? The screen comes in, it shakes, okay? And that's kind of satisfying. It gives you the sense that these things are bowling balls, all right? And when these things hit the ground, they create a splash, okay? Particles go flying everywhere. I think I have some better versions of this. Every time, oh, this is kind of cool. Oh, yeah. Well, this is the blur, the background blur is kind of neat. What other scenes do we have? What other scenes can I show you? Can I show you this scene? Okay, let's check out this one. Boom, boom. Oh, this looks awesome, okay, right? So we've got these kind of sparks, right? These sparks that come in and really kind of sell the impact as it hits the wall and then it hits the floor, right? We've got this very warm environment, okay? So I'm going to show you not only particles and screen shake, okay, but I'm also going to show you post-processing effects. For instance, one of the reasons that this scene looks so warm, okay, it looks like we're in a furnace somewhere, is that we've got this vignette on the borders of the screen that is red, okay? It gives this sense of heat and warmth to the entire image. By the way, what happens in many games when you are low on health or you take damage? Any ideas? Yeah, how does the typical modern game indicate to you that you are low on health or you just suffered damage? Usually via a vignette with red on the borders of the screen. If you're playing a military first-person shooter, it is basically a bloody screen effect, okay, where it makes your vision look like you got a bunch of blood on your eyes, okay? Anyway, you know what that reminds me of? We talked earlier about positive feedback loops and negative feedback loops. So here's your little quiz. When you take damage and get shot in a first-person military game, and your screen becomes covered in red and obscured and bloodied so that it's harder to see, do we have a negative feedback loop or a positive feedback loop here? What do you think? Take a shot.
Is it positive since as you take damage, it's easier to take more damage?
Bingo, absolutely. Positive feedback loop, okay? It accentuates the change in the system. It's the snowball that starts rolling and then it just keeps rolling faster and harder and gets bigger, right? It's the runaway feedback. So in this case, you have taken damage. And because you've taken damage, you are now more likely to take damage, okay? Leading eventually to your death, your KO, and respawn in that game, okay? And so you might ask yourself as a designer, is that something we really want? When our players are on the ropes, do we want them to be likely to get knocked out? Isn't it a bit more exciting if a player's on the ropes and they're 1 inch from demise, but then they find a way to kind of fight their way back and escape the situation? And they're exhilarating, right? They're super excited and like, I can't believe I just survived that. This is awesome, right? I feel super great. But maybe the person who is on the attacking end doesn't feel so great because their prey just got away, right? So these are the kind of things you want to notice as a game designer, and you want to be very careful about, okay? You want to be very purposeful about these things. Anyway, okay, so this is the kind of stuff that I want to implement. And so we're going to go ahead and do that. We're going to take our break at about 11:55 today, and so we've got a little bit more time. What I want to do is I want to create a new scene, okay? I'm going to create a basic built-in scene, okay? You've seen this before. We just have a camera, we have a light, and we have nothing else. I'm going to name this scene. What should I name this? I'm going to name this just Juice Scene Fall 25, okay? In this project, by the way, all of this stuff is available in the course code repository. It's a Juice demonstration project. So you can get all of these things right away if you want to just grab the code and use them. But we're going to build them together, okay? So what I want to do is I want to create just a basic scene here, and I'm going to put down some ground, okay? Let's go ahead and make this a little bit wider, okay? Let's go ahead and bring this to 000, origin. Okay, why is my camera all the way down here? What's going on? 000, is this the right? Oh, no, I mistyped. 000, okay. 000, why was it 8? Not sure what's going on. Let's go ahead and bring this camera up, give it kind of a better camera view. Learning your hotkeys can make messing with scenes much faster, okay? And now that I've got my little piece of ground here, I want to create a rainy scene. I want to create a rainy scene with really cool water droplets. Maybe, has anyone seen the film Bug's Life or Ants? Okay, these films came out very nearby each other when I was growing up. I think in like the late 90s or maybe early 2000s. And these were films about, portraying ants, okay? And these films, I think, I don't remember Ants very much, but I remember Bug's Life. Just a really, really fun film. For instance, water droplets. If you look at this device right here that Flick, the main character, has made, it is a telescope that has a big bubble of water on the end. And so I want cool water droplets like that as well. They feel big. Maybe this is a game where you play as an ant. That'd be really cool. So let's go ahead and create that. So what are we going to do? Let's go ahead and create a sphere. And I'm going to bring it over here to the... well, I guess I'm going to try to. Let's see if it will for me. I'm going to drag it up here. I'm going to give it a rigid body, okay, so that it will fall. And I want this to feel like a droplet of water. I want it to kind of mush, and I want it to deform a little bit, okay? I want this droplet of water, when it hits the ground, I want it to kind of poof, right? In a spring-like fashion. And so let's go and watch what happens. This doesn't really look like water to me. I'm not convinced, okay? What I want here, is for this water droplet to be able to squish, okay? Squish, squish, squish. This is such a powerful effect. You can use it just about anywhere to great impact. And this is going to be our spring effect, okay? Hooke's law. Anyone remember Hooke's law, right? Physics 140, it's the kind of thing that you can actually look up on Wikipedia, okay? Has anyone ever used Wikipedia for to look up mathematical concepts? One thing that always drove me away from doing this is that you want to look up something that is, you want a straightforward definition or explanation of a concept. Like Hooke's law, okay? How can I model how a spring works and the forces that act on a spring? And then you get here and you just get absolutely smothered in just an enormous amount of discussion, okay? Suddenly there are matrices getting involved here, and you don't quite understand why. There are all sorts of graphs, okay? You've got derivatives happening in here. Very, very confusing. The hard part of using Wikipedia articles is usually finding the small chunk you actually care about. In this case, this right here is what we care about. Thankfully, it's kind of toward the beginning. And so we have this equation right here, Fs. So the force acting on a spring is equal to Kx. Okay. What is K? What is X? Another thing that makes math and physics in general very hard to study is that these fields are addicted to using a lot of variables with the worst variable names you could possibly imagine. If you created a variable called K in your EECS 183 or EECS 280 code base, you'd be losing points for style, okay? Why? Because when people see K for the first time, they haven't the faintest clue what on earth this is. And unfortunately, in some cases, it can be annoyingly hard to look up what it means, okay? Does anyone know what K means in this context? Yeah. It's a spring constant. That tells you nothing, okay? What is it actually used for? Do you know? What does it do? When we mess with it, what does it change?
Springiness.
The springiness. Oh, great. This is stiffness, okay? Stiffness. If you have a very stiff spring, i.e. you have a value of K that is very high, right, your spring is going to very quickly, right, go to where it wants to be, its resting state, okay? If you make K low, it's going to be a very mushy spring. It takes a while to get where it wants to go, okay? X is a delta value. The spring wants to be at its resting state. If you pull it apart, there's a delta, okay? That X, that delta of where it wants to be versus where it is. If you push it in, you have that X, it's the delta as well, okay? So here, that's kind of trying to tell you that, hey, X, right? You pull it, X is large. You smush it, X is small. When it's at its resting state, the spring has an X of 0. And that should make intuitive sense. If this X is 0, there's no change in the spring. There's no force acting upon it to change it, okay? So this is all kind of, maybe it makes sense to you, maybe not so much, okay? One of the cool things about having these all written out and figured out is that sometimes you don't need to understand the intuition behind why springs are modeled by this equation. If you can implement this equation accurately anyway, you will just get a spring, okay? That's kind of cool. So here's what I want to do. I want this ball right here. First of all, I don't want it to fall right now, so I'm actually going to get rid of the rigid body for now. But I want this ball, when I press spacebar, I want it to go boink in a really nice spring-like, juicy, water droplet-like fashion. Okay, so how can I do that? Well, I'm going to create a component here called hooks, and I'm going to call hooks scale. I'm going to call hooks scale 4 because this is the 4th time I've done this demonstration. Okay, and the reason I call this is because it's using Hooke's law to impact the scale of the game object. Okay, with a spring, Hooke's law affects the position of the end of the spring. Okay, but here we want to apply Hooke's law to the scale. So I'm going to double click and we're going to see if we can implement this. Okay. All right. I'll tell you, the first time I implemented this, I had to do like 3 or 4 different experiments because I kept messing it up. Okay, that's simply the way this goes sometimes. So you shouldn't feel bad about it at all. Okay. So what I'm going to do here is I'm going to create a new function called process hooks effect, okay? Now, if you look at this equation right here on Wikipedia, it is F equals Kx, okay? So F equals Kx. Why do we care about F? What does F do to us? Well, if you wonder why F is so important, it'll become a bit more clear when you remember another equation in physics, a very famous one. Have you ever heard of this equation? F equals ma? Have you ever heard of that one? So F equals ma relates force to the acceleration of your game object. Okay? And acceleration is what we need because acceleration is the rate of change, okay, in our rate of change. So this A, if we can calculate this A right here, then we know how much we should change our current velocity, okay? First of all, we should probably have a velocity. It starts at 0, okay? It starts at 0 because our scale is not changing at all. And so, how can we get this A? Well, we can do some really basic algebra here. Let's take this A. This m is equal to 1. For us, we don't care about mass. We're going to assume that m is 1. Well, if this is 1, multiplying by 1 is pointless. So let's get rid of it entirely. In other words, F for us is equal to A. Okay? So we can just get rid of this, and I'm going to replace this F with A. We now have our acceleration is going to be equal to k times x. Okay? So we should try and calculate these things if we can. What is k? Well, k, let's just choose a value for it for now. Let's choose like 0.1. I'm not sure how good that's going to be. We're going to have to play with it, okay? And we should probably calculate our x as well. Do you remember what x is? X is the delta, okay? The difference between where we are and where we want to be. So what do we want to be? Well, we want our scale to probably be 1.0, okay? Our local scale, if you look at the scale, the x, the y, and the z, they're all 1, okay, for this droplet, okay? And so let's go ahead and let's just set it to be 1. That's where we want to be, minus where we currently are. So one way we can figure out what our current local scale is by going local scale, okay? But we've got a problem. What's our problem here? The problem is that this is a float, a single number, and this is actually a vector 3 different numbers, okay? So what we actually have to do, and this is a little bit of a hack, I keep getting blocked by the autocomplete. I'm gonna do just .x, okay? We're gonna assume here that the x, the y, and the z is always gonna be the same for these droplets. Now you can change that later and upgrade that later if you want to, so that they can be separate. And that would probably look really cool. But for now, we're just going to leave it like this. So we now have our k and our x. We can now adjust or calculate our a, our acceleration. Okay? It's going to be k times x. Okay? Awesome. But are we done? No. Because we've calculated a, our acceleration, but now we have to use it. If you remember what acceleration is, it is the derivative of velocity. It is the thing that changes velocity. In other words, if we have our velocity, every frame, it's going to change how much? It's going to change by a, okay? And so, let's give it a shot, okay? If I call this function every frame, Hooke's effect will be applied. But there's a problem. Oops, let's, oh yeah, that's fine. There's a problem. What's our problem going to be? When I start the game here, we're already at where we want to be. Our scale is already 1. If our scale is 1, then our x is going to be 1 minus 1, which is 0, which means our acceleration is 0, which means our velocity, which starts at 0, is just going to stay at 0, so nothing happens. What do we need to do here? Well, we need to have a cheat code, okay? We need to have a cheat code because when I press the space bar, I want to kind of just lightly change the scale, okay? The scale that I'm at. Or maybe the velocity. Maybe I'll change the velocity instead. Let's do if input.getKey down, keycode.space. Okay, nice try, AI. We're going to set our velocity. Let's make our velocity tinier. So if I make the velocity negative, it's going to want to go in first, which is kind of what we want to test, okay? Hitting the ground, morphing, and getting smaller. Okay, so velocity, let's subtract 0.25 from this. Okay? Now let's see what happens. All right? Let's see. This will push the velocity off of... oh, this is going to be funny. I'm going to press spacebar and nothing happens. Okay? Nothing happens. Why? Because we are manipulating our velocity now, but you know what we're not doing? We're not using it. It's just a variable. Okay? We're not actually using it to alter our local scale. Okay? So transform.local scale. Okay? If this is truly our velocity, then our scale needs to change based on velocity. Okay? Now, we can't do this because local scale, again, is a vector 3 numbers, and this is just one number. Okay? And so we can deal with this by multiplying our velocity by vector 3.1. Okay? This is the vector 1, 1, 1, and so this converts our velocity into a vector 3, and now we can do the add. Okay? So our local scale changes, and that new local scale is fed back into our system, which then changes our local scale. What do we have here? This is called a feedback loop. We just talked about it, okay? The output, our changing scale, is fed back into our system, which results in the scale changing, okay? And so let's see what happens now, okay? We should be stable. I'm going to press spacebar in 3, 2, 1. And nothing happens. Okay, what's going on here? So let's do some debugging. Cheat codes. This is running if input.key down. I press space. Okay, velocity minus equals this. Velocity is going to go down. Oh, what's up?
Well, I think this code's connected to the camera, not the sphere.
Oh, really?
Yeah.
Did I accidentally do that? Oh, you're right. I put it on the main camera. Our camera was probably going like this. Now, the camera doesn't really use the transform scale for anything, to my knowledge. But it would be funny if it did. So let's go hooks scale 4. Okay? All right. Okay, 3, 2, 1. It's not a positive feedback loop because it's not blowing up and becoming the size of the universe. But it's also not a negative feedback loop because it's not stabilizing. What's the problem here? We've created this spring-like effect, but we've forgotten something really important about springs. Springs that exist in the real world. There's this thing called friction. When you take a spring and you put energy into the spring by pulling it apart, that potential energy, when you release it, it becomes kinetic energy and it moves, right? But it doesn't move forever. It's not a battery that provides and contains the energy forever and preserves it. What happens to the energy? Eventually it comes to rest. Why? Because of friction, okay? And so we need to introduce the concept of friction, all right? So let's do this. Velocity is going to increase by a, but velocity is also going to change. We need a dampening factor. Let's go float dampening factor, okay? Let's call this 0.99. Every single frame, we're going to lose 1% of our energy, okay? Another thing, we probably want to take this k and move it out here as well, since it's kind of like a parameter. And I'm going to do something in particular that's going to be useful. I'm going to make these all public. Why would I make these all public? What's the point? Yes? Yeah, exactly. So I can mess with them in the inspector. And we're going to do that when we come back. But right now, let's just press the space bar and... All right. It's a little bit crazy at the start. It's a little bit too big, but not too bad, right? Not too bad. Actually, let's go ahead and try this really quickly. Let's try and get some slightly better values. Press space, okay. Velocity, dampening factor. I can actually watch my velocity right there. I'm going to make this k a little bit... Actually, you know what? What I really want is not velocity to be public. What I want is the bump power, okay? Let's go public float. Currently, it's 0.25 F. I don't know if I want that, though, right? It looks like we're bumping too hard. So I might make that smaller. Let's make this 0.15, okay? And let's try this out. Space. Okay? right? It's a little bit smaller. This is very stiff, okay? So I think I want to make this a little bit less stiff. Ooh, look at that. Wow, isn't that much nicer? Much smoother, okay? I'm going to make it even smaller bump, 0.1, okay? Let's make the dampening factor, let's leave that for now. Let's make 0.1. Ooh, okay. Let's make the bump even smaller, 0.5, okay? Boink, boink, like that. What about a dampening factor that's a little bit bigger? Okay. Nah, that's not quite enough. I want it more springy than that. Okay, like that maybe. That would make a really nice button, like clicking on something. That feels pretty good. How about this? Okay, slightly bigger. Okay, I'm going to play around with this. Dampening factor larger. Okay, this is looking a little bit better. I kind of like this. Okay, maybe 8, and then maybe this a little bit smaller. Ooh, I like that. Isn't that nice? So you put in all this effort to get it just right, and then you're going to lose it if you end the game. So what do? ... Copy component. Okay, I lose all the values, but then I paste them right back in, and we're golden. Okay? And so this is a really, really good start, right? This Hooke's law is something you can use in many different situations to get many different effects. You can use it on scale, but you can also use it on position and all of that. So what I want to do is I want to take our 5-minute break, okay? And I will see you back in 5 minutes, and we'll look at some of the problems with what we just did, okay? And we'll continue implementing juice in 5 minutes. See you then. Yeah, what's up?
Cooking Unity related question.
Okay, go for it.
So there's this bug that's been like
Sorry, can you give me 50 seconds? So. Okay, what's up?
Yeah. So there's one like bug that's like playing my code. I don't think
Oh, you're opening it. Yeah.
But
So tell me about it.
The problem is, so let's say my character spawns like in this corner here, and then I have some like sprites in this area of the room here.
Yep.
Sometimes when the camera pans to this area, it's not there. But like my player still takes damage from the enemies and the traps.
Oh, chances are sprite sorting order. If it's there but you can't see it, sorting order problem.
But I see it in the scene. I just don't see it. Like, can I show you?
No. Yeah. I need a moment. Thanks.
Yeah.
Cool. Okay, come on.
Yeah. So, as you can see, there's like a spike here.
Yeah.
But there's no spike here, but I can like go over and take damage.
Yeah. Okay. So let's go and look at the spike. Okay. So you fell off. So go back there.
Also, like my cameras don't spawn in. There shouldn't be a sorting.
You feeling okay?
So, yeah, I'm not sick. I don't think it's like a sorting issue problem because I don't have a background.
Contact layer.
It shouldn't really matter. Like it's just this specific stuff. Like this part, I guess. everything else spawns like that's not in this area of the map, but I am duplicating them when I'm like dragging them to make the map.
Yeah, I don't think that should be a problem.
It helps make it more intentional.
Don't know. That is so weird. I can see it in the scene view.
I have to watch it.
There's something called the frame debugger, which will show you kind of the process things are being rendered in.
Oh. I'm guessing you haven't had this issue before.
No, not really.
I adjusted this. Oh yeah.
Spike. It's not marked as static. What about your camera? Main camera, render type, base, default, culling map, fusion culling. What happens if you do this? If you take the player. Okay, take the player. Okay, let's get rid of everything except their sprite render. So, like, sometimes Unity simply has bugs.
Yeah.
And it's frustrating, but you can usually design around them. So you know that Unity is currently rendering the player properly. You know it's currently rendering the ground properly. So take the ground and then switch it to a spike.
But this is a prefab, though.
Okay, so it's rendering, fine. Where's your spike image? This? No. What image does it use?
It's just a triangle. But it's also not just the spike, it's also the enemy as well. That I have.
Okay. So here's a functional visible spike.
Okay, so I'm guessing it just...
So what you could do is you could take this and say, hey, this is now what the new spike is.
Okay.
And now you have
scripts and everything.
Yes. So now you have a new spike object. Failed to create prefab. Huh? Brutal. Okay. So good. Now they're all working. And maybe you'll discover that in these existing sprites, there's something that messes everything up.
But that doesn't explain why everything else doesn't vote as well. It's just this specific area.
It's Unity bug. So it could be a Unity bug. It could be something else. I can't explain why until office hours. So come to office hours tonight, and we can dive deeper if you care.
What time is it?
Look on Canvas. Okay, everyone, let's get back to it. So we have our little springy effect, right? If we're making a droplet, a water droplet, this is a good start, okay? If you have any sort of enemy that you want in your game and you want the enemy to show some damage, when you hit them or when they take damage, you might want to do something like this, okay? But we're going to discover here that we actually have a bit of a problem, okay? If this is a water droplet, I want it to fall. I got to give it its rigid body back, okay? So let's go ahead and bring this down. Let's bring it over here. Now, when I press the space bar, something strange is going to happen. Watch very, very closely, okay? The ball falls, and when the ball falls, I want it to spring. Okay, so I press space bar, okay? When the ball springs and is on the ground, something strange is happening to it. Okay? Do you notice what's happening to the ball right now? The ball is doing something that we wish it was not. Okay? And if you can't see, I'll pause the game and I'll make it a bit more clear. Play focused. Okay? Watch this. Watch what happens to the ball. What is happening? The ball gets small. This allows the ball to fall. But then the ball needs to spring and get big again. And so the ball pushes down against the ground and hops into the air. It also hops into the air when we go small, right? It goes small, the ground's no longer underneath us, we have to fall a bit because we're in the air. This may look innocuous to you, not a big deal, but it will give you tremendous headaches going forward if you leave this in, okay? In general, special effects, visual effects, make your game very complicated, okay? You want to keep the visual effects as separate as possible from your underlying game. Here's an example. Imagine that this is actually a platformer game. And when our character touches the ground, we want them to do this little mushiness. We want them to kind of, shrink a little bit, right? To show off the force of them landing, right? If you ever watch someone land after a big jump, they don't just boom, right? If you do that, you're going to break your legs, right? No, your legs kind of spring, okay? They cushion the impact of the fall, of the landing, right? You jump and then like that, and then you spring back up, right? And so imagine we have a character in our game that we want to do that. They land and we do this effect. Looks good. The problem, though, is that what can a platforming character not do when they are in the air? The character is in the air right now. What can the player not do?
They can't jump.
Yeah, they can't jump. It kind of looks like they should be able to, though, right? So imagine this scenario. The player wants to land on the ground and then immediately jump again because they're on a small platform that's going to shrink or something. It's going to, crumble. So the player does a jump and it looks great. The player goes to land, and as the player is landing, the player presses the button to jump again. But the character doesn't jump. Why? Because they're technically in the air, and so the player goes running off the platform to their death. And then they go on Steam and they leave you a bad review, right? And they rage. Because really, it's kind of our fault, okay? The player couldn't really know that at this split second, oops, because we added this visual effect, sometimes our character no longer jumps when you want them to. That's a bit of an issue, okay? So, in general, as a principle, we do not want the visuals of our game to interfere with the underlying gameplay mechanics of our game, okay? And so, we have to do something about this. We have to do something about this. And one thing that we can do is called the view approach, also kind of known as the costume approach, okay? This is where we're going to have not one game object, okay? Not one game object, but we're actually going to have two, all right? So this game object right here, I'm going to name it Droplet, not all caps, okay? I'm going to name it Droplet, and then I'm going to create another droplet, okay? Another droplet, but I'm going to call this one the Droplet View, all right? And so this droplet view is going to have only one job. Represent the visuals of the game object. Okay? This droplet is only going to have one job. Manage the gameplay mechanics and physics. Okay? It doesn't care about aesthetics. So here's what we'll do. This droplet is going to lose its mesh renderer. Bingo, it's now invisible. It's going to lose its mesh filter. It's going to lose It's Hooke's scale 4, okay? But it's going to keep its sphere collider and it's going to keep its rigid body because these are two components that are completely fundamental to our gameplay, how we collide with things, okay? Now, this view right here is going to keep its mesh render and its mesh filter, but it's going to get rid of the sphere collider. It doesn't collide into anything. It's just the visuals, okay? It's going to get rid of the rigid body. It doesn't have any physics, but it's going to keep Hooke's scale because this is a visual effect, okay? And so now, what do we need to do? We need to tell the view to follow around our droplet. How can we do that? Super, super easily, okay? Let's create the classic follow target component, and I'm going to call this follow target 4 because this is the 4th time I've done this component, okay? So follow target 4, what does it need? Well, it needs to have a target, okay? So public game object target. And actually, we kind of sort of want that to be a transform component because that's the only thing we're going to care about on the game object anyway, okay? So there we go, target. And then every single frame, we're going to move to that target, okay? Let's go vector 3, desired position equals target dot position. Then we're simply going to move ourselves to that position. It's pretty simple, okay? Very, very, very simple. So we're going to go ahead and we're going to drag that droplet in. So now we have a view which is only visuals. It can't collide with anything. It doesn't affect the gameplay at all. And now we have a droplet that the view follows around, and it does only have collisions, okay, and rigid bodies and stuff like that. Another way to think about this is that we have the real droplet and then the view of the droplet. Separating these two things is going to be very nice for us, okay? Let's go ahead and play the game. Could you tell that this is not just the original droplet? No, it looks the same. And in fact, we get benefits from this because I'm going to go look again, and now when I press spacebar, we're going to get a different result. Okay, ready? Look at the seam, space. Look at that. There's no bouncing up into the air, okay? The actual object, you see the green sphere here? The green sphere, the collider, is the actual object. So let's look at what happens to that. Absolutely nothing, right? The underlying actual true droplet isn't moving at all when we do this special effect. Okay? By the way, I've got another example here. I don't have the cheat code in yet to show this to you. You're never going to believe me. But when I take you to EECS298.com and I show you these cool characters, okay, they're running around, they're jumping, it looks fantastic, right? Okay? This is just a pill. It's just a pill. Okay, it's a capsule game object. And these characters just follow that capsule around. When you want to change your character, you don't change the capsule. You don't even change the player game object. The only thing you change is you despawn this view and you spawn in a different one. And the view looks different and it has some different animations, but the underlying gameplay has not changed because it's still just a capsule underneath everything, okay? This is how a lot of games work in industry, right? What is beneficial about doing it this way? Well, number one, no matter what cool animations we put on these characters, it won't mess with the gameplay, okay? Imagine, if, this character has an arm that's swinging around. If the arm slightly grazes the spike, you get killed, right? It might be annoying. Players might avoid characters that are really lanky or have cool animations because now their hitboxes are really unwieldy and nasty. Or maybe when this character does the little kick animation in the idle, right? It would cause our character to hop up because the kick hits the ground, and if you hit the ground, it'll force you up, right, due to simple physics. And that'd be awful, right? You wouldn't want that. So this is a very, very common pattern. And when you're making your P2, when you're making your P3 especially, I encourage you to try and separate the visuals of your game object from the actual underlying game object. It will make your life a lot easier, especially if you have multiple characters, which most of our games do not have, in part because, yeah, it's kind of hard. And if you haven't taken 298, you don't know how to really create characters so much, but it's a really, really powerful thing. Now, we've got some problems here. Okay, we have some problems, but yes, question. Ooh, that's a really good point. It's a very good point. Why can't we simply do this? I'm going to get rid of the follow target component here. Boop, it's gone. Okay, and I'm going to just parent it to the droplet. Okay, and we can make it fit like that. Right? Why can't we just do this? And I'll tell you, in many cases, you can do this. But here's the thing. If you parent one game object to another, you will get the position of the parent, but you will also, unfortunately, get the scaling changes as well, and the rotation. In many cases, you don't want all of those. In some cases, in the past, I've wanted the scale of the parent and the position of the parent, but I didn't want all of the rotation of the parent. I only wanted it on the y-axis and not on the x or z-axis. And unfortunately, parenting is a very powerful concept, but it's also a very clumsy one. Okay, it's all or nothing, right? So if you want the position of something, but you don't want the scale, if you want the position and scale, but you want only one axis of rotation instead of all three, sorry, like parenting just doesn't work for you. So I tend to try and kind of avoid parenting. You're welcome to use it. And if it works for you, it's really nice. It's a natural fit. So go for it. But what I'm actually going to show you next time is how to kind of get the best of both worlds. Because we've got a problem right here. Our big problem is how are we going to distribute this stuff? We have two game objects, so we somehow have to remember to bring out both of them and hook them up every time. Imagine if you wanted to have droplets. Let's go. Let's create a folder real quick. Prefabs 2025. Okay. Imagine if you wanted to have a droplet prefab. Okay. And I want to put a bunch of droplets in the scene. So let me just bring my droplets out here. Oh yeah, great. Wonderful. This is super nice, right? Look at this, right? How many droplets do I have in the scene now? Can anyone tell me? You can, but it's really annoying, right? This is awful. Your game designers aren't going to realize there are a bunch of droplets here unless they pour through the drop-down kind of view right here, the hierarchy. So this is nasty. You also have to make sure that you bring in a bunch of droplet views, and then you have to hook every single droplet view up so that it knows which one to follow, and it's just a nasty mess, okay? Nasty. So the question is, how are we going to deal with this and make this nice and convenient again? And the answer is going to be kind of cool, okay? It's not super nasty. It's pretty nice. And I'm going to show you that when we come back on Wednesday. I'm also going to show you a bunch of other techniques as well on Wednesday, including cool post-processing stuff, so you can make your game look all cinematic as well. Okay? All right, everyone. Sorry for being a little bit grumpy today. It's probably going to last for a week or so. But best of luck to you on your P2 as you finish that up. Remember, it doesn't need to be gigantic. Be focused, okay? Remember Guru, okay? Remember those games we showed you a few lectures ago, okay? You just need, even 5 minutes is definitely enough, okay? But focus on a small number of mechanics and really explore them and escalate smoothly, okay? And you do that, you're going to be in great shape. Okay, I'll see you Wednesday. Everyone online, I'll see you later as well. Bye-bye.